so sorry for posting so late. I'm sorry for that. I'm trying to get into a routine over that. So I promise you the next video will be there like earlier. Say about, Sunday night. Yeah, that's easy. Sorry for posting it so late. I'm a bit of a procrastinator. Yeah, if you didn't know. But I'm getting that fixed, and so yes. And if you can, the like button feels lonely, so I want you to hit it. Wait, is hitting it proper? I don't know. But hit the like button, hit the subscribe button, and thanks. DITTO Lab signing out.
Be strong.
A place so far out, it's considered third zone of the solar system. It's so cold that it's colder than Neptune. This place is known as the Kuiper belt. It's a large region with millions of small icy objects, some measuring more than 60 miles wide, and some, like Pluto, are over 600 miles, 1,000 kilometers wide. And it's not just made up of ice. It's made up of rock, water, and many other frozen compounds like ammonia and methane. The region is named after the astronomer Gerald Coupe. I don't think that's his actual, but I don't think that's how you pronounce his name, but I don't know how to say it much. He published an amazing scientific paper in 1951 that speculated about objects beyond Pluto. Astronomer Kenneth Edwards also mentioned that there might be objects beyond Pluto. I don't know about you, but I think I like the, Kenneth belt. But that's just me. He also published papers in the 1940s, and thus sometimes the Kuiper belt is sometimes referred to as the Edward Kuiper belt. Some researchers also prefer to call it the trans-Neptunian region and refer to the Kuiper belt objects, KBOs, as a trans-Neptunian objects, or TNOs. Okay, that's cool. A lot of things. Whatever your preferred term is, the belt occupies an enormous volume in our planet, like in our whole, solar system. And the small worlds that inhabit it have a lot to tell us about the solar system's early history. The Kuiper belt is one of the largest structures in the solar system, besides the Oort cloud, but that's another video in itself. The heliosphere and the magnetosphere of Jupiter is an overall shape is like a puffed up disk or donut. Its inner edge begins at the orbit of Neptune, around about 30 astronomical units from the Sun. 1 AU, or astronomical unit, is the distance from Earth to the Sun. The inner main region of the Kuiper belt ends about 50 AU from the Sun, overlapping the outer edge of the main part of the Kuiper belt. The Kuiper belt is has a second region called the scattered disk, which continues outward to nearly 1,000 AU, with some bodies on orbits that go even farther beyond. So far, over 2,000 trans-Neptunian objects have been catalogued by observers, representing only a tiny fraction of the total number of objects scientists think are out there. In fact, astronomers estimate there are hundreds of thousands of objects that are larger than 60 miles, 100 kilometers wide or larger. However, the total mass of the material in the Kuiper belt is estimated to be no more than 10% of the mass of Earth. Astronomers think that the icy objects of the Kuiper belt are remnants left from from the bigger formations, like planets, in the solar system, similar to the relationship between the main asteroid belt and Jupiter. It's a region that might have come together to form a planet had Neptune not been there. Instead, Neptune's gravity stirred up this region of space so much that the small icy objects there weren't able to come together into a large planet. The amount of material in Kuiper belt today might just be a small fraction of what was originally there. According to one well-supported theory, the shifting orbits of the four gas giants, Jupiter, Saturn, Uranus, and Neptune, could have caused most of the original material, likely 7 to 10 times the mass of Earth, to be lost. The idea is that there is in the solar system's early history, Uranus and Neptune were forced to orbit farther from the Sun due to shifts in the orbits of Jupiter and Saturn. As they drifted farther outward, they passed through the dense disk of small icy bodies left over after the giant planets formed. Neptune's orbit was the farthest out, and its gravity bent the paths of countless icy bodies inward toward the other giants. Jupiter ultimately slingshotted some of these icy bodies either into an extremely distant orbit to form the Oort cloud. Again, the Oort cloud is its own video, or out of the solar system entirely. As Neptune tossed icy objects sunward, this caused its own orbit to drift even farther out, and its gravitational influence forced remaining icy objects into the range of locations where we find them in the Kuiper belt. Today, the Kuiper belt is slowly eroding itself away. Objects that remain there occasionally collide, producing smaller objects fragmented by collisions. Sometimes the comets and also dust that's blown out of the solar system by solar wind. That's pretty cool, right? The Kuiper belt represents an enormous donut-shaped volume of space in the solar system. While there are many icy bodies in this region, we broadly refer to the Kuiper belt as KBOs, or trans-Neptunian objects. TNOs, they're fairly diverse in size, shapes, and colors, and importantly, they're not evenly distributed throughout space. Once astronomers started discovering them in the early 1990s, one of the early surprises was that KBOs could be grouped according to their shapes and the sizes of their orbits. This led scientists to understand that there are several distinct groupings or populations of these objects, whose orbits provide clues about their history. Which category an object belongs to has a lot to do with how it has interacted with the gravity of Neptune over time. Most of the objects in the Kuiper belt are found in the main part of the belt itself, or in the scattered disk. A large fraction of the KBOs orbit the Sun. A large fraction of the KBOs orbit the Sun in what's called the classical Kuiper belt. The term classical refers to the fact among the KBOs that these objects have orbits most similar to the original or classical idea of what the Kuiper belt was expected to be like before astronomers started actually finding objects there. The expectations was that if there were objects beyond Neptune, they would be in relatively circular orbits that aren't tilted too much from the plane of the planets. Instead, many KBOs are found to have significantly elliptical, and tilted orbits. Thus, to some extent, that the classification of KBOs still reflects our evolving understanding of this distant region of the solar system. There are two main groups of these objects in the classical Kuiper belt, referred to as cold and hot. These terms don't really, besides the name, they don't really, refer to temperature. Instead, they describe the orbits of the objects, along with the amount of influence Neptune's gravity has on them. All classical KBOs have similar average distance from the Sun, between about 40 and 50 AU. Cold classical KBOs have relatively circular orbits. They aren't tilted much away from the plane of the planets. On the other hand, hot classical KBOs have more elliptical, I really have to get that correct, and tilted orbits. This means that the cold variety spends most of their time about the same distance from the Sun, while the hot ones wander over a large range of distances from the Sun. The differences between these two types of bodies in the classical Kuiper belt have everything to do with Neptune. The cold classical KBOs have orbits that never come very close to Neptune, and thus they remain cool and unperturbed by the giant planet's gravity. Their orbits likely haven't moved much for billions of years. In contrast, the hot classical KBOs had interactions with Neptune in the past. These interactions pumped energy into their orbits, which stretched them into elliptical shape and tilted them slightly out of the plane of the planets. Most of the objects in the Kuiper belt are found in the main part of the belt, or in scattered disk. But there are also a couple of additional families of objects that orbit the Sun interior and exterior to the belt. These additional groups of the objects probably came from the Kuiper belt originally, but have been pulled out of the main region by the gravity of Neptune or perhaps another massive planet. Detached Kuiper belt objects have orbits that never come close to the Sun. Closer to the Sun than about 40 AU. This sets them apart from other KBOs, which spend at least part of their orbits in the region between 40 to 50 AU from the Sun. Because their orbits don't come close to Neptune's distance from the Sun, negative 30 AU, detached objects seem unlikely to have been pulled out of the Kuiper belt by interactions with the giant planet. Scientists think it's likely to be some other force, such as an undiscovered giant planet in a very distant orbit, the gravity of a passing stars, or gravitational perturbations. I knew this word, but as the Kuiper belt was forming long ago. Sedna is an example of a detached KBO. The closest it comes to the Sun is 76 AU, while at its furthest it travels out to minus 1,200 AU. Pluto was the first Kuiper object to be discovered in 1930. At the time, before astronomers had reason to expect a large population of icy worlds beyond Neptune, today it's known as the king of the Kuiper belt, and it's the largest object in the region, even though another object of similar size, called Eris, has a slightly higher mass. Pluto's orbit is said to be in resonance with the orbit of Neptune, meaning Pluto's orbit is in a stable, repeating pattern with Neptune's. For every 3 orbits completed by Neptune, Pluto makes 2. In this situation, Pluto never comes close enough to Neptune to be affected much by its gravity. In fact, even though its orbit crosses Neptune's orbit, Pluto gets physically closer to Uranus than it ever does to Neptune. and binaries. A fairly large number of KBOs either have moons. That is significantly smaller bodies than orbit them, or binary objects. Binaries are pairs of objects that are relatively similar in size or mass to the orbit around a point, a shared center of mass, that lies between them. Some binaries actually touch, creating a sort of peanut shape, creating what is known as a contact binary. Relationship to comets. Kuiper belt is a source of comets, but not the only known source. This known source comes from the Oort cloud. Objects there occasionally collide with the collisional fragments, producing smaller KBOs, as well as dust that's blown out of the solar system by solar wind. Pieces produced by colliding KBOs can be pushed by Neptune's gravity into orbits that send them sunward, where Jupiter further corrals them into short loops lasting 20 years or less. These are called short-period Jupiter family comets. Given their frequent trips into this inner solar system, most tend to exhaust their violet ices fairly quickly and eventually become dormant or dead. Comets with little or no detectable activity. Researchers have found that most near-Earth asteroids are actually burned-out comets, and most of them would have started out in the Kuiper belt. Many comets crashed into the Sun or the planets. Those that had close encounters with Jupiter tend to be ripped apart or tossed out of the solar system entirely. The other source of comets is the Oort cloud, where most long-period comets on a highly tilted orbit come from. So, we've learned a little bit about comets, and we've learned where they come from. But what else will we find? Maybe you'll find something. So keep on watching, and bye. DITTO Lab signing out.